This is Precalculus video lecture number 2, graphs of equations in two variables. So if you'll recall, to find the x-intercept of the graph of an equation, you substitute or let y equal 0 and then solve for x. And then similarly, to find the y-intercept for a graph of an equation, then you would let x equal 0 and solve for y. Just think you're going to plug in 0 for the opposite variable of the intercept that you want. And then once you get your answer, make sure you always write it as an ordered pair, okay? Very important. So let's look at some examples here. Find the intercepts and then graph each equation by plotting points. So to start off with, just label your work clearly. Okay, let's find the x-intercept or intercepts. We'll see. Sometimes you might have more than one. So to find the x-intercepts, I'm going to substitute in 0 for y. So I'm going to have 0 equals negative x squared plus 1. Solving from here, I'll just move the negative x squared over, so I get x squared equals 1. Take the square root of both sides, so x is equal to plus or minus 1. Don't leave your answer like this. You have to write it as an ordered pair. So the x-coordinates of the x-intercepts are plus or minus 1. The y-coordinate is 0. We substituted in 0 for y. Always 0 for the opposite variable, okay? And then now let's move on to the y-intercept. So again, I'm going to substitute in 0 for the opposite variable. So in this case, since I'm finding the y-intercept, I'm going to substitute in 0 for x. So negative 0 squared plus 1, so I get y equals 1. But no, we are not done. I'm going to write this as 0, 1. All right? So nice. Now let's go ahead and graph it. This is enough information for me to graph it because I recognize the equation. If I have y equals x squared, I know that that's going to be a parabola. And with these 3 points, that's enough. If you don't recognize it, because we haven't covered the lesson on recognizing families of functions based on the equation, then just make a table and plot more points if you need. But I don't need. So here we go. So I have plus or minus 1, 0. That's right here. And then 0, 1. And then this parabola is opening downward. Make sure you put arrows on your graph as well. That's crucial. So you should have everything labeled on your axes and scaled. And then also add in, this is the x-axis, this is the y-axis. Okay, very nice. Let's look at another example here. We have 4x squared plus y is equal to 4. So again, I'm going to label my work. Let's start off finding x-intercepts. So I'm going to substitute in 0 for y. So we have 4x squared plus 0 equals 4. So that means 4x squared is 4. X squared is 1. This is playing out just like the last problem, isn't it? So I get x equals plus or minus 1. Remember, we're not done. You have to write plus or minus 1 comma 0. Now I'm done with my x-intercepts. Y-intercept. So similarly, I'm going to substitute in 0 for x. So I have 4 times 0 squared plus y is 4, which gives me y equals 4. So I just end up with 0, 4. All right. Now, if you'll notice, this is actually another parabola, and it's just been shifted, which we're going to get into in the later lesson. But this equation is y equals negative 4x squared plus 4. Okay, so it's very similar shape to the previous parabola that we just graphed. Anyways, it's opening downward. I know that the intercepts are at 0, 4, plus or minus 1, 0. So that's enough for me to graph it. But again, you're always more than welcome at this point to just make a table, plot more points if you need to. Okay, x-axis, y-axis. Good. Now let's move on to testing for symmetry. Now, to test the graph of an equation for symmetry, with respect to the x-axis, what you're going to do is replace y with negative y in the original equation and simplify. And then if the result ends up being an equivalent equation, so you get back the same equation that you started with, then the graph of the equation is symmetric with respect to the x-axis. So let's think, what would a graph look like if it's symmetric with respect to the x-axis? It would mean you could fold it over the x-axis, right? And you have a mirror image. So one classic example is a parabola that's opening along the x-axis sideways like this. Okay, and then here I want the test to make sense to you. So let's pick a point that would be on the parabola. I'm graphing x equals y squared here. So here's a point, say it's at 4, 2. Okay, now what other point, if we know our graph is symmetric with respect to the x-axis, has to be on there? Has to be on the graph as well. Could you figure out what the coordinates of that point are? You say, why, yes, it's 4, -2. And that's precisely what the test is doing. It's generalizing, or it's testing for every single y coordinate, because you're replacing y with negative y. So for every y, there should be negative y also on the curve or on the graph if you have symmetry with respect to the x-axis. So that's how the test works. Okay. Next, if you're testing for symmetry about the y-axis, you're going to replace this time x with negative x in the original equation and simplify. And then if an equivalent equation results, I'll show you exactly what that would look like, then that means the graph is symmetric with respect to the y-axis. Now the previous two that we just graphed, the parabolas in the first example, were symmetric with respect to the y-axis. Notice we had 1, 0, -1, 0, and I could fold them along the y-axis and get a mirror image. And again, whatever point is on the graph, so is negative x, y. So if you have xy, negative xy is also on there. Lastly is symmetry about the origin. Okay, so when you test for symmetry about the origin, you replace x with negative x and y with negative y in the original equation and simplify. And if an equivalent equation results, then the graph is symmetric with respect to the origin. So what's an example? One common one is y equals x cubed. But you know, trig is so important. Let's not forget our trig. How about sine x? That's another great one to remember. Is symmetric with respect to the origin. So I'm going to graph it for you here. Y equals sine x. So we have pi over 2, 1, 0, 0. And then notice in test for symmetry about the origin, you replace x with negative x and y with negative y. Meaning if pi over 2, 1 is on the graph, then so should negative pi over 2 and negative 1 be on the graph. And this is what symmetry with respect to the origin looks like. Basically, it's a double fold. You fold the graph about the x-axis. And so if I reflect it over the x-axis, you get this kind of an image. And then you reflect it over the y-axis, and then you get your symmetry, if you can see. All right. Now, later on, when you're in calculus, you're going to be so grateful that you can test for different kinds of symmetry because it'll save you a lot of work. So right now we're building up all the tools that we need for that day. Here we go. So for this first example here, we're going to find the intercepts, x and y intercepts, and then test for symmetry. And we're going to test for all three kinds of symmetry. Make sure you show your work exactly the way I'm doing. Okay, label everything clearly. And if you are one of my students and you don't show all your work the way I'm doing, you will not get full credit on an exam. So here we go. This is an A+ example. Symmetry. Let's do that first because we just learned it. Okay, so I'm testing for x-axis symmetry. Again, just think I'm going to substitute in for the opposite variable, just change the sign. So if it's x-axis symmetry, then I'm going to replace y with negative y. And I get x squared plus y minus 4 equals 0. So you think to yourself, is this an equivalent equation? Is this the same equation that I started with? Look at it. Do they look the same? No, they certainly do not. So what does that tell you? We do not have x-axis symmetry. Okay, now let's test for symmetry about the y-axis. This time I'm going to substitute in negative x for x. Make sure you put those parentheses anytime you substitute in a negative value for a variable. So I'm going to have now positive x squared minus y minus 4 is 0. Is this the same equation that I started with? Is it equivalent? Why, yes it is. So that means this graph is symmetric with respect to the y-axis. Okay, let's go ahead and test for the origin. So this time I'm going to replace both variables. So I'm going to replace negative x for x and negative y for y. And then simplify. So negative x quantity squared, that's x squared, plus y minus 4 is 0. Is this the same as the original? No. So that means we do not have symmetry with respect to the origin. Okay. Now let's work on the intercepts. So x-intercept, I'm going to substitute in 0 for y. So I have x squared minus 0 minus 4 is 0. Let me just move that negative 4 over to the other side. So now I have x squared equals 4, which means x is plus or minus 2. Do I leave my answer like this? No way, only if I want to get marked off. You have to write your intercepts as ordered pairs. So this is plus or minus 2, comma, 0. Okay, very good. And then last part is the y-intercept. So we're going to have here x squared, but I'm going to substitute in 0 for x. Minus, excuse me, minus y minus 4 is 0. And then I can just move y over to the other side. So I have negative 4 equals positive y, which means my y-intercept is negative 4, but write it as an ordered pair, 0, negative 4. Okay, beautiful. So that problem's complete. Okay, I tested for all kinds of symmetry, and then I found the intercepts and wrote them as ordered pairs. Now let's look at another example. Okay, just a little more interesting, a little more spicy. So I'll start off by testing for symmetry again. This time our equation is y equals x to the 4th plus 1 divided by 2x to the 5th. So let's test for x-axis symmetry. Remember, for x-axis symmetry, I'm going to substitute in negative y for y equals x to the 4th plus 1 over 2x to the 5th. Now there really isn't any cleaning up or simplifying to do. So you look at this equation, is it the same or equivalent to the original? No way, there's an extra negative on the left-hand side, so no x-axis symmetry. What about y-axis symmetry? So this time I'm going to substitute in negative x for x. So I have y equals negative x, put those parentheses, and then the 4 goes outside of it, plus 1 divided by 2 times negative x to the 5th. Now let's simplify. So in the numerator, I'm going to have positive x to the 4th plus 1, and then in the denominator, I have negative 2x to the 5th. Now compare. They're very similar, but no, it's still not the same as the original. I have that extra negative in the denominator, so no. What about origin symmetry? Are you doubting if I even need to test it? Shame on you. You could have no symmetry for x-axis, no symmetry for y-axis, but still have origin symmetry. So let's see what happens here. I'm going to replace this time y with negative y and x with negative x. And let's see what happens. So on the left-hand side, I have negative y. What about on the right-hand side? So now I have positive x to the 4th plus 1 in the numerator, and then I have that negative 2x to the 5th in the denominator. But notice on both sides, I have an extra negative. I could easily get rid of it if I just multiply the whole equation by negative 1, which I'm totally allowed to do. And then now I get back the exact same equation that I started with. Y equals x to the 4th plus 1 over 2x to the 5th. So yes, we have origin symmetry with this graph. My goodness. So just let it be a lesson that even if you don't have x-axis symmetry, even if you don't have y-axis symmetry, you do still need to test for origin symmetry because it could pass, okay? Good, now let's move on to the intercepts. So I'll rewrite the equation here, that way we won't have to keep referencing it. So it's y equals x to the 4th plus 1 over 2x to the 5th, okay? So for x-intercepts, remember I'm going to substitute in 0 for y. So 0 equals x to the 4th plus 1 over 2x to the 5th. Always clear out the denominator, so I'm going to multiply both sides by 2x to the 5th. So on the left-hand side, 0 times anything is still 0, and then I have x to the 4th plus 1. Okay, well, if I move 1 to the other side of the equation, I get x to the 4th equals negative 1. Now let me ask you, is it possible to take something, raise it to the 4th power, and get a negative? Not for any real numbers. So that means there's no x-intercepts. None. Oh my goodness, okay. Well, what about y-intercepts? Well, remember, for y-intercepts, you substitute in 0 for x. And so if I try to go and do that, I have 0 to the 4th plus 1 over 2 times 0 to the 5th. But remember, that would give me a 0 in the denominator, which would make the expression undefined. In fact, our graph or equation does not exist when x is 0. So again, we don't have any y-intercepts either. Okay, so no intercepts, no x-intercepts, no y-intercepts. Don't feel bad about it, it's not your fault. Okay, last example here. 4x squared plus y squared is equal to 4. So let's start off, let's test for symmetry. So we'll check for x-axis symmetry first. So remember, I'm going to substitute in negative y for y, put those parentheses around the variable. Exponent goes outside of it, okay, equals 4. So then I have 4x squared. If I square negative y, it becomes positive. Is this the same as the original equation? It sure is. So yes, we have x-axis symmetry. Now what about y-axis symmetry? So I'm going to substitute in negative x for x. So then we have 4x squared plus y squared is 4. Is this the same as our original equation? It sure is. So we get a resounding yes. And then lastly, origin, you probably can guess that this is going to be a yes also, right? So we have 4 times negative x squared plus negative y quantity squared equals 4, and then both terms become positive, so I have 4x squared plus y squared is 4, so we get another yes. So we've got symmetry all around. Now what about intercepts? So x-intercepts, I'm going to substitute in 0 for y, so I have 4x squared plus 0 squared is 4. So I have 4x squared equals 4, just divide by 4, so we'll have x squared equals 1. So again, x is plus or minus 1. Don't leave your answer like that. This is plus or minus 1 comma 0. Very good. And then y-intercept, or intercepts in this case. So we have 4. Substitute in 0 for x squared plus y squared is 4. So that's just y squared is 4, which is y equals plus or minus 2. So we get 0 plus or minus 2 for our y-intercepts. Are you curious what this is the graph of? You'll learn soon enough that this is the graph of an ellipse. Yes, I'll graph it for you really quickly. And if you're just dying to learn about it, you can jump ahead and watch the video on conic sections, graphing an ellipse. But you'll notice here's our y-intercepts at 0 plus or minus 2, and then x-intercepts at 1, negative 1. So this is our ellipse here. And then you can see that it has all three kinds of symmetry, x-axis, y-axis, as well as origin. All right. Very good. So that concludes this lesson. Stay tuned. We're going to be graphing lines in the next video.